Thank you for allowing me to make this short presentation via this technology method, as I enjoy some of my retirement time. I'm going to talk briefly about the structures and environment requirements for composted bedded pack facilities. And I'm really going to focus on three areas: a layout, access to the building, and the walls, which are the major structural components that we need to focus on in the bedded pack versus just a standard freestall barn. In the layout, we're looking at three distinct areas. We got the bedded area or resting area. We got a scraped feed alley where the cows will be standing to eat. Then we got the feed alley, which is typically for drive-through feeding of the animals, and each one has their own special requirements. The bedded area, we'd like to allow 85 to 100 square feet per cow, and that's for a full-size Holstein. The smaller breeds or heifers can handle less area. And this bedded area is typically separated with a 4-foot-high concrete wall. One of the things we're looking for is providing 270 days of manure storage in this area. Some people talk about 180 days. For much of the area, 180 days allows or forces you to be managed around the manure, where 270 days works much better. The bedded area, we need to think about how deep it is, and that's from the front to the back of the barn. And you start out looking at the feed bunk length. If we need 24 to 30 inches per cow, and then we can figure out how deep it has to go based on the total area. Another thing many farmers think about, and I would encourage you to also think about, is can it be converted to freestalls? Not that this system doesn't work, but at times bedding that once was available is no longer available, and if you can easily convert it to freestalls, it gives you more flexibility down the road. The other thing, and we'll talk a bit more about it later, is equipment access, because you will be getting into that bedded area twice a day for your stirring it, as well as periodically bringing in fresh bedding and cleaning it out. Separation from the scraped feed alley is typically a 4-foot-high concrete wall. Post and plank could be used, but concrete structurally is much better. Then there's a discussion about, do you put a fence on top or not? Would the cows have to walk over it to get pushed off? And most farmers do not, but some do, and I have not heard any major problems one way or the other. Then we like to have at least 2 animal access locations, and that's access from the scraped feed alley into this bedding area. It allows the animals to get in and out better. The other thing to think in terms of ease of getting to the feed and to the water as they need it, and that at least 2 locations makes that easier. The scraped feed alley is basically the same as a freestall barn, but since we don't have animals backing out into it from a freestall, we can get by with 10 to 12 foot wide feed alley. Again, we want it grooved to reduce slipping. Keep in mind that this is a liquid, and we need to design the manure transfer to a liquid manure storage someplace. And think about how you're going to manage when you're cleaning. We design it so we can have gates that would confine the animals to the bedded area while you're cleaning. Some farms are able to manage it so once the cows are moved to a milking parlor, they can get in and scrape that alley before they have many animals back into it. But keep that planning and animal management day in, day out in mind in planning this area. Then your feed alley, like with freestall barns, 16 to 22 foot wide, depending on the size of the equipment. You put it 3 to 4 inches above the feed scrape alley so that the cows reach down, but not quite to their feet. And the decisions on headlocks or feed rail is the same as a freestall barn. And keeping in mind, if you do a headlock, that may determine the length of the barn per cow, which you can then use in calculating the depth to provide the necessary bedded area. Access, as I've talked about, and you'll hear more about if you haven't already, is twice a day stirring. Then you're periodically cleaning it out. 1 or 2 doors, preferably doors at each end so you can move in, move through. Typically you want gates across the doors so that you can have the doors open in the summertime to help with the ventilation. Keep in mind that this bedded area is going to increase and you're going to have ramped area coming up and down. Then the cow access from the feed scrape alley is going to be the same thing. We talked about the two. I'd like to see a step up to the bedded area, and then the bedded is going to slope up as the bedding fills up in the bedded area, and the cows come and go this way. Water is critical, and the same amount of water is needed as for a freestall barn. We'd like to locate the waters so that any spillage goes into the liquid part and not onto the bedded area. Most people will do an offset into the bedded area along the scrape alley and set the waterers on a little raised platform so that they can continue to scrape the scrape alley easily, and any water that's spilled also comes over into the scrape alley. Just a look at an example layout from a 100 cow dairy, and you service the 2 walkways, 1 on each end and 1 in the center, 4 waterers located along the feed alley, and then you drive by feed major, and this is a simple one with just a roof overhang and outside drive alley for the cows. Under construction, you'll see the grooved scrape alley, the wall separating the animals from the feed, and then the wall between the scrape alley and what will be the bedded area with the green post on there, which would say that they're probably going to put some type of railing or fence up there to keep the animals from coming through. Then your bedded area, notice the plywood in front of that cow, additional protection to keep the water from splashing into your bedded area to help keep it drier. And then you can see there's simple railing to keep on top of the bedded wall. You know, the concrete wall with the post on top of the concrete wall on the left side. So since the scrape alley is liquid manure, you have to have a way to handle it. Their solution was just a small pit that they would scrape into and either pump out or access ramp for cleaning out. The wall structure is one of the differences between a freestall barn and these buildings. We've got this 4-foot high concrete wall. It needs to be designed to handle the loads pushing against it. You have your loads from your building, because typically the posts are fastened on top of the wall. You have some loads from the manure as it builds up, and we structurally design that with an equivalent fluid density, oftentimes around 35 pounds per square foot. Essentially do a structural design assuming that acts like a liquid pressing out on the wall. The other thing is we have the equipment going on, moving around there, and that will also place some forces on that wall. And so it's ideally designed for at least 100 pounds per square foot uniform load on the face of the wall from the equipment pushing out. And then our post loads, I have to anchor them so that they don't overturn, don't get lifted up, don't get slid sideways. Bit structural work that you need to make sure a good structural engineer helps with that design. The post design is basically the same as your post frame building. You got your wind loads, you got your truss loads. The difference with the setting on top of the post, we have it pinned at the base instead of supported by the ground when you put the post in the ground. So you need to really look at your end walls, which serve as a shear wall to help transfer the horizontal wind forces down to the ground. And again, a good structural engineer can help you get a good design. Briefly about ventilation, and being a composted barn doesn't change the ventilation needs for the cows. We use the same approach as the freestall barns. We have the 14 to 16 foot high sidewalls above the solid wall with curtains. We have an open ridge, 2 inches per 10 foot of building width, and it can be straight open, or you can do an overshot roof as your desire. The critical thing is to make sure that you provide adequate opening, and then we should have our eave openings as well, that as we do in our freestall barn. For summer comfort, even with the barn fully open, the cows need additional cooling help, and the circulation fans, sprinklers at the feed manger, both help. And with the sprinklers at the feed manger, we're seeing that by starting operation at 70 degrees, that it's working well for the animals. That these high-producing cows are starting to get stress, show stress at 70 degrees. At 70, you may run it a minute out of 5 or a couple minutes out of 5. And as it gets hotter, you may run it longer times or more frequent. Thank you for your attention, and I hope you enjoy the rest of your conference.